Hi guys, my name is Katie.
My name's Amrita.
My name is Katie.
And my name is Jordan.
For our project lab, we decided to redesign the stapler to be transparent so that a user will be able to see where the staplers are going to be placed.
So for our product description, our product is a stapler. So it's a mechanical device that drives a small metal staple through papers, and it's useful for joining documents. In terms of user description, our users will primarily be older children and adults, and these children will primarily go to school, and these adults will primarily work desk jobs or are in academia.
So our target market will include office supply stores such as Staples, Office Depot, and the like. And our competition currently on the market is staplers with no transparent material and staplers with only a transparent handle and base.
So the image on the right shows a stapler broken up into its various parts. The main components are the handle at the top, the base of the stapler, and the crimp area. So from the perspective of the user, these are the components that decrease the visibility of the user when they're attempting to perform the action of stapling. This makes the otherwise simple task a bit more challenging and makes it difficult to align the staple exactly where you want it. For our redesign, we will make the handle, base, and crimp area transparent so that we can increase visibility of the staple delivery and decrease human factors related errors.
As Jordan mentioned, the redesigned stapler will include a handle, base, and crimp area that are all made of polymethyl methacrylate, which is abbreviated as PMMA, which is also known as acrylic. As seen in the images below, the transparency of the handle, base, and especially the crimp area will allow the user to see the location of the staples as they are delivered.
So our prototype's dimensions will be similar to standard staplers on the market. So this means that our prototype's length will be around 5 inches, the base height will be 0.3 inches, the handle height will be 0.5 inches, and the width will be 1.5 inches. And so to the right, you can see an image of our prototype's CAD design, where we changed the material of the handle, the base, and the crimp area to be made out of acrylic. And the dimensions follow as mentioned before.
So from our hierarchical task analysis, we found that there may be a few potential human factors issues. These include difficulty separating the top and bottom of the stapler to load staples, insufficient visual cues and inability to locate the correct part of the stapler, dexterity issues, the stapler springing shut too quickly and potentially causing injury, or being fatigued from high repetitions of stapling action. And these consequences are on the next slide.
So from our literature review and our evaluation of the ruler worksheet, we identified more human factors issues associated with the use of a stapler. We found that repetitive or frequent use of a stapler could potentially lead to long-term issues such as arthritis, carpal tunnel, tenosynovitis, or slight forearm or upper arm discomfort. Flexion and extension of the wrist, which is a necessary muscle movement for this action, has been found to be highly related to carpal tunnel syndrome. We also found that palmar and gripping loads have been linked to upper limb disorders, and loads applied at the base of the palm produce larger pressure changes. Additionally, tight hand grip can cause direct compression of the nerve against the bony structures when squeezing the handle towards the base to pierce the staple through the paper.
So to combat the health issues that Jordan mentioned before, we came up with 2 options to improve these human factors issues. Our first option was to integrate a curved handle. This would therefore decrease the incidence of flexion and ulnar deviation of the wrist and reduce the stress concentrations that compress the arteries and nerves. This would therefore reduce the likelihood of carpal tunnel syndrome developing in users. Another solution would be tool grips. These have a significant effect on carpal tunnel pressure and grip strength. However, since we have designed our stapler to be a clear handle, a tool grip would cover that handle, kind of negating the fact that it is clear.
So finally, in terms of manufacturing costs, in general, manufacturing costs should be 40% of the selling cost, and the average stapler selling cost is around $10. So because of this, the manufacturing cost should be a total of $4. So this table kind of outlines what we were thinking the manufacturing cost for each component is. And so that's pretty much the end of our presentation. Here are our references, and thank you everyone for your attention.